Okay, so another method of finding or approximating the derivative using a given equation is by finding the average rate of change. So what we did in the previous method is pretty similar to what we're going to be doing here. We're going to stick with the same equation, except this time we're going to come up with an equation that compares a bunch of average rates of change if we have different x values really close to 5. So let's just start off with the average rate of change equation. So r of x equals the p of x of any x value, but in this case we're going to be sticking with x values really close to 5, minus the p of 5, all over the distance between x and 5, so x minus 5. And from the previous slide, or previous video possibly, p of x minus 0.3125, which is the value you get when you plug in 5 to this equation in place of x, over x minus 5, equals r of x. So what this gives us is basically the average rate of change between the x values, instead of, in the previous video, we just found the p of x values. So I plugged in all this stuff in a calculator. Notice how there's an error here, because if you plugged in 5 for x, we would have 5 minus 5, which equals 0, and we have learned for many years, I guess, that you cannot divide by 0, so that is why we have this error message. So that's why we can't plug in 5 directly, and instead we have to stick with numbers really close to 5, such as 5.01, 4.99, or if you wanted to be even more accurate, 5.00000001. So what we can do is take the average of these two, and in order to do that, we'll just add -0.2159 minus 0.2174 and divide that by 2, which gives us -0.21665 grams per minute, which, if you recall from the previous video, is really close to what we got. So there's a pretty good chance that this is the correct answer. Yay!